Hello, and welcome to Algebra 2, Chapter 3.5, Graphing Linear Equations in 3 Variables. So, for a short amount of time, we're going to leave 2D world and enter 3D world, and we're just going to learn how to graph a little bit there. So, what we have to start with, though, is a three-dimensional coordinate system. Notice the XY plane, which is this green plane. Notice it comes out at you if you're looking at it 3D. So if you were looking at the corner of the room, it would be like the floor that's coming out at you. The XZ plane would be one of the walls, and the YZ plane would be the other wall. Okay. So when you graph in 3D world, we have to graph what's called an ordered triple because you have 3 dimensions. Here's our ordered triple, x, y, z. So we're just adding z on. Okay. So when you plot it, you would first go the length along the x-axis, then the length along the y-axis, and finally the length along the z-axis. And we do have 8 octants now instead of 4 quadrants. Okay. Think about that. You'd have 4 above the x-axis and you'd have 4 below the x-axis. And so it's the first octant is where everything is positive, and that's the one you're looking at right there. So when you graph, you have to follow each axis one at a time. So if we plotted 2, 3, 5, you would start at the origin and you would come out 2 on the x-axis. Then you would go over 3. Okay, now 3 might be here though. There's my 3, and so they're kind of at an angle. So 1, 2, 3, you'd come out 3, which would put you there. And then we want to go up 5. So that might be 1, 2, 3, 4, 5. Let's see here. Those, though, are also at an angle because you're sitting kind of above where you need them to be, because it's 0 here. If you were out on z equals 0, you'd have to actually come down. So these come down this way, and so you'd end up then at that point right there. And so we're going to try to be as accurate as possible, but there's a little bit of wiggle room. So try one without lines already there. So we're going to plot 3, -1, -5. Okay. So, and notice here you have all 8 octants, if you can think about this, and this is the positive x out front, the positive y over to your right, and the positive z goes up. So to start out with x is 3, you're going to come out to 3 on the y-axis, so you're there momentarily. Then it says y of -1. So see that that tiny distance there from 0 to -1? You're going to go over that distance. Not make 2 marks, just 1. So now you are at -1. And then we're going to go down 5, and so really you just want to kind of count this distance. So you're going to go maybe 1, 2, 3, 4, 5. That then is the point. Okay, so you're moving those distances in those directions. So let's try it again. -5, 3, 4. So the first big question is, where are you starting? You are starting about there. That would be -5. You're going to do a positive 3, so we're going to come over 3. 1, 2, 3. Okay, and then you're going to go up 4 from that point. So we're going to go 1. I know you're doing better with the pencil than I am on the iPad. 2, 3, 4. So let's put it about there. Okay, so, and when you have your final graph, you don't need all of this, you just really need your final point. Okay, let's see if we can do it. 2 more times here. So 1, 3, negative 2. So you're going to start out on 1. So, just I would move my pencil out here to 1. 3 means we're going to go which way 3? We're going to go to the right 3, so that would be about 1, 2, 3. And then we're going to go which way 2? We're going to go down to 1, 2. That then is my point. Okay, last one. Negative 2, negative 3, positive 4. So where do we start? Start at negative 2. Negative 3 goes which way? We're going to go to the left. 1, 2, 3. And then positive 4. 1, 2, 3, 4. So we would end right about there. So far all we've done is just plot points. Okay. So the next thing we're going to do is we're going to plot equations, linear equations in fact, because there's no squares or cubed, everything is just to the first power. So standard form here is ax plus by plus cz equals d. Not all a, b, and c can be 0, otherwise you wouldn't have any variables left. Any ordered triple xyz that works is a solution, okay? And we want to graph all the solutions. And so instead of a line, this actually graphs a plane. Okay, the graph of a linear equation in 3 variables is a plane. So if you remember from geometry what a plane looks like, that is what we're graphing, is we're going to graph a plane. So how do we do it? Well, we're going to graph using our intercepts. Okay, so x-intercept, what do I know about it? Well, if you remember, y is 0 and z is 0, because if I want to be on this x-axis someplace, both y and z have to be 0 to be on that axis. So you can look at it just like that equation, in which case x equals 10. So let's go ahead and put a point on 10. There's 10. Okay, so then the next thing I want to do is I want to find my y-intercept. Well, what do you know about your y-intercept? X is 0 and z is 0, because for you to be on the y-axis, those two have to be 0. So 3 times 0 would be 0, 5 times 0 would be 0. We have negative 12y equals 30. We do 30 divided by negative 12. We get negative 2.5. Okay, so y-axis, negative 2.5 is roughly there. Okay, and then I want to find my z-intercept, in which case I know that x and y are both 0. So if x and y are 0, let's get rid of that one being 0. X and y are 0, so then I'm going to get z equals, about z equals 6. Alright, so 2, 3, 4, which puts us up here. Okay, so what you're going to do now, to draw in a whole plane can look pretty confusing. So we're just going to draw in the triangular region that connects these intercepts. So with the straight edge, you're going to connect these 3 points. Now, this one is not very impressive. It should give you just a very small triangular region here. And you're going to fill it in. Some of the other ones we do are going to look better. But let me show you, graphed that whole plane. This is the plane we just graphed. And so if you look at it closely, here z is 6 right here. X was 10, and so that's going to happen out here, I think. And then y was 2.5. And so we then connected those, and we just graphed this part of this plane. We didn't graph the whole plane. So this is just from a different angle and you get to see it a little bit differently. Alright, another one. X minus 2y plus 2z equals 6. So first of all, we need our x-intercept, okay, in which case y and z are both 0. So we just get x equals 6, okay, plot that. Make sure you're coming the right way on the x-axis. And then we want our y-intercept, in which case x and z are both 0. So that would be, make sure you note your negative there. Get negative 3 on the y-axis. Okay. And then your z-intercept, in which case x and y are both 0. Your z would be 3. Okay, so then all you're going to do is just connect those with straight lines and shade that in. There you go. Alright, so the last thing we're going to talk about is a function of two variables. So typically we evaluate functions of one variable. So in this case it looked just like f of x. But now we're going to evaluate functions of two variables, which could be f of x, y. So to write a linear equation in x, y, and z as a function of two variables, what you do, it's pretty simple, is you solve for z, and then you're going to replace z with f of xz. So typically we say f of x equals y. Well, now f of xy equals z. Okay, so let's try. Write 3x minus 12y plus 5z equals 30 as a function of x and y. So you want to solve for z. So get z by itself. So we're going to subtract 3x and add 12y. So it's going to be 5z equals, and I'm going to do my variables in order with my constant at the end. So divide by 5. So z equals negative 3/5 x plus 12/5 y plus 6. And then you have to write it f of xy equals negative 3/5 x plus 12/5 y plus 6. There is our function. Okay, and then we want to evaluate it, so we're going to find f of negative 2, 2. So we're going to do negative 3/5 times negative 2 plus 12/5 times a positive 2. Notice I just put those in for their corresponding variables, plus 6. So this is 6/5 plus 24/5 plus 6, which is 30/5 plus 6, which is 6 plus 6, which is 12. Alright, we have two more examples. Write x minus 2y plus 2z equals 6 as a function of x and y again. So to remember, our first step is to do what? Solve for z. Okay, so let's subtract x and add 2y. So that gives us 2z equals, I'm going to write them in order with our variables first, negative x plus 2y plus 6. Divide everything by 2. And you can, at this point, go straight to doing f of xy if you want, because that's what you found is z, negative 1/2 x plus y plus 3. So there's my function. And then to evaluate it, I'm going to put 0 in for x and negative 2 in for y. So f of 0, negative 2 equals negative 1/2 times 0, which you could skip that part, minus 2 plus 3. Negative 2 plus 3 would be 1. Okay, we got the left. You're packing food supply crate for a canoe trip. The crate weighs 12 pounds and it will be filled with boxes of granola bars, each weighing 1.5 pounds, and boxes of macaroni, each weighing 0.75 pounds. Write a model for the total weight of the crate as a function of the number of boxes of granola bars and macaroni. So we want to make sure that we include both in there. Alright, so let's call this F. Actually, let's call this function W because you're finding the weight. And it's a function of the granola bars and the macaroni. So to figure out the weight, it's going to be how much the granola bars weigh, which is 1.5 g. Okay, so if I take one granola bar, it's going to weigh 1.5 pounds. This is hopefully a box of granola bars, by the way. If you take 2 granola bars, it'd be 3 pounds, plus how much the macaroni is going to weigh, which is 0.75 times m, plus we want the box itself because it says write a model for the total weight of the crate, okay, so plus 12. So there's our function, and then when we go to evaluate it, we're going to say, okay, let's take 15 granolas, 15 granolas and 25 macaroni. So then it would be 1.5 times 15 plus 0.75 times 25 plus 12. Get the calculator out. And I get that it is 53.25 pounds. Don't forget your unit. Alright, that's what we got for this lesson. Since this was a new format, I want to know your opinion. Right now, if you would go to the blog and post several sentences comparing this app, which is called Explain Everything, versus the EduCreations. What do you like better about one or the other? Or just what do you like about one, what do you like about the other? But it needs to be several sentences, and if you do so, I'll give you 5 extra credit points towards your semester extra credit. Alright, needs to be done before you come to class next time. Hope you have a good day. We'll see you later.